Now I will generate the SCA descriptors and structural code for the platform and waveform models. We will switch back to the platform and generate the descriptors and code for any components where we are not using precompiled binaries. In this example, this is just the audio port device, the WFPGA proxy device, and the RF CTRL device. The code and descriptors have been generated for the 4500 platform. As you can see, it has produced this generated source project. Now I will do the same for the demo waveform. And that completes the code and descriptor generation. I have generated two source projects, one for the platform and the other for the demo waveform. In my targets view, I can see my targets in the make files. I will start with the platform and will compile all of the source files. In the case of the platform, this involves compiling the core framework IDL, all device interfacers, and obviously the devices themselves. This is running a generated makefile which invokes the VxWorks toolchain and the Spectra Orb IDL compiler to build the libraries. The remainder of the components in the platform model are precompiled binaries that it will pick up out of the core framework. Now that it is finished compiling, we can take a look in the project, and we should be able to see our audio port device, WFPGA proxy device, and the RF CTRL device binaries. I'll do the same for compilation on the generated demo waveform model. This is exactly the same except it would hold more components. All 5 components in the application are generated and compiled, so this compilation will take a bit longer. The next step will be to gather together the binaries for the platform components along with the descriptors for the application assembly and components into a deployable set and actually deploy them onto the DTP4500 platform. As a result, when you power on your DTP4500, it is going to automatically boot VxWorks and then boot the SCA platform model that is shown on the screen. Now that the DTP4500 is powered on and the platform is running, I can connect to the Spectra CX SCA runtime monitor to my board where we can actually see the platform running. I have this monitor object in the model which contains details of the board and how to connect to it. You can see that it does not display the device manager and domain manager as they are implicit. If I open the SCA monitor, it will connect to my board and display the actual running platform. What you can see are the audio port device, the WFPGA proxy device, the RF CTRL device, the executable device, and the log service that we saw in our model. They are actually deployed and running on the DTP4500. What I've also done is deploy the descriptors and binaries for the application model, which we generated and compiled earlier. I've copied those onto the target file system of the DTP4500. There are many ways of getting the files onto the target. You can use NFS if you have that built into your VxWorks kernel. You can even unplug the USB card and connect it to your host to copy the files. I have simply transferred them onto a USB stick. What I can do with the runtime monitor at this point is install the application factory, and what you'll see here is the runtime monitor has inspected the file system and found the SAD file for our demo application. If I choose that, it will create the application factory corresponding to the SAD file, which it has done, and now the factory is available to create application instances. Now I can create instances of the application. If I switch to the terminal, we should see some output from the application factory as it creates the application. As I mentioned previously, I've already deployed the runtime versions of the binaries, so there is not much output from the binaries. Now we have an instance of our application running on the DTP4500. So we can see if I switch back to the application assembly model that we have the file input, the mod, demod, resampler, and assembly controller. The monitor is connected to the running system, and we can now see the instances of those components running on the target. When an application is created, it is not initially running. We have access from the runtime monitor to the lifecycle operations through which we are able to start the application. Before we can start the waveform and transmit a signal over the air, we must configure the transmit frequency of the RF CTRL device. In this case to 446.000625 MHz. And also set the value of the file transfer enable property to be true on the file in-out component. If I switch to the serial terminal after I've started the application, we should see the audio port device is printing out a dot for each sample that it receives, and the DTP4500 is actually transmitting the audio signal over air. I can stop the application, and you can see that the processing has ceased, and then from the SCA monitor I can also release the application, and here you can see the application instances have disappeared. You can also see that there has been some activity unloading the application. I can also uninstall the application factory itself, and now I am back to a bare platform running on the DTP4500.